So today's lesson, it's a short lesson on the Simplex method, solving maximum problems that are in standard form, and this may be section 4.2 in your textbook. And so you could download these PowerPoint slides if you would like to use them and write on them to take notes, or just take notes on your regular tablet paper. So our outcomes for this lesson, just to specify what we're going to go over, is to solve maximum problems in standard form using the Simplex method, and determine if a Tableau is final or if it requires additional pivoting or indicates no solution. And just to let you know where these problems are coming from, I didn't just make them up. I'm actually using the Finite Mathematics and Applied Approach Sullivan book, as well as your Loud book. So these are the two books that I will be using, or that I actually used to generate the questions. They came straight out of these two textbooks. So if you're ever wondering and you wanted to reference them, you could. But let's kind of go over a quick review first. So one thing that I do want to review that was in section 4.1, or the previous section, is how to read a Tableau. So it says write the solutions that can be read from the following Simplex Tableau. And so that's an important concept that you really want to understand to help you to be able to solve properly today. So I do want to review that, and I want to review some vocabulary. For instance, I want to talk about basic variables, and I call them BVs. So our basic variables we always want to identify initially. So my BVs are my basic variables, and we want to identify those. So my basic variables are those variables who in their columns, like X2, has all zeros and one non-zero digit. So we'll say that X2 is a basic variable. Not X1, because I don't have all zeros and one non-zero digit. X3 is not a basic variable. S1 is not a basic variable, but S2 is a basic variable, and we'll just call Z an honorary basic variable. So it has zeros and one non-zero digit. So when we are looking to, or attempting to read the solutions, that is what we're looking for first. So I'm going to start with my BVs. And so I look at this number, and I'm just reviewing, so I know you know this, and I will multiply that, treat it as the coefficient of X2, and set it equal to what's on the right-hand side, RHS. So I'll say 1X2, or just X2, you know the 1 is optional, is equal to 4. And I know that S2 is equal to, so 1S2 is equal to 16, what's on that right-hand side. And I also know that Z is equal to 28. And if you remember, all non-basic variables are automatically equal to 0. So therefore, when we talk about non-basic variables, or we can call them non-BVs in red, we know they are always equal to 0. So X1 is 0, X3 is equal to 0, S1 is equal to 0, and that's it. So if I am going to write the solutions and read them, this is saying X2 is 4, X1 is 0, X3 is 0, S1 is 0, S2 is 16, and Z is 28. So if we were solving, it's almost as if we think about it graphically, we're at a corner point where X1 is 0, X2 is 4, and X3 is 0, and it's a corner point that maximizes the linear objective function, and we would have a maximum of 28. So just to kind of review how to read your solutions, I think this is going to be important for what we're going to be doing today. Okay? All right, so let's move forward. See if I can get this screen a little bigger. Well, no, it's okay. All right. So let's jump right into our steps. So there are going to be 9 steps, and these came out of the textbook that I referenced, the Lyle textbook. These are in that textbook if you're using it, and there are 9 steps to using the Simplex method. And in the previous sections, we talked about steps 1, 2, 3, and 4. And today's lesson begins with 5, 6, and then on the next page, if you have this printed out, you'll see 7, 8, and 9. So the previous, the previous section, the previous lesson was numbers 1 through 4, and we're going to continue with 5. So you know how to determine the objective function, to write all of your necessary constraints as if you have a word problem that you are setting up. You know how to convert each constraint into an equation by adding slack variables, and you know how to set up your initial Tableau. Well, now I want to talk about how to find your pivot element, because once you set up your initial Tableau, you need to pivot, and that's what we're going to work on. Steps 5 and 6, they are outlined here for you, and 5 and 6 will teach us how to determine your pivot row. We talked last time about how to find your pivot column. So that's what I'm about to work on at this time. So I'll go back to these, and you can leave those up if you like, but I am going to start and show you how to find your pivot element yourself. So I'll go back to those notes in just a second, but taking this initial Tableau, this is an initial Simplex Tableau, and we want to be able to pivot so that eventually we can find a maximum if it exists. And so in order to do that, we first have to find the pivot column, and we need to find our pivot row. So if you recall, the pivot column is going to be, we look at this bottom row, we call it the indicator row, and we look at the bottom row and find the smallest number, or I should say the most negative number. So the most negative number is negative 25. So once you find the most negative number, this is your pivot column. So we know that our pivot column will be this column, and so I'm going to identify it. Okay? Now I have to find my pivot element. And to find my pivot element, I have to consider which of these will be my pivot row, if any. So my pivot row, when I look up from the bottom row, my pivot column, so this element, negative 25, when I look upwards, it's very important to know that we're looking for positive numbers. So I need a positive number in order to be able to pivot. And in this case, I can't use the 0. I will not use the negative. So here's my positive number. So in this case, I have 0, I have a positive 4, and I have negative 2. But if we want to follow these instructions specifically, which is important, I want to kind of go through and read them to you, and you can look at them. Okay, for just a second. So when I look up, I know that this is going to be my pivot element, and therefore this is my pivot row. If I did not know that, what I could do is follow these instructions. And 5 says, locate the most negative indicator, and if there are such 2 indicators, choose the one farther to the left. So this is about the pivot column. So we've done that. We found the pivot column. Now we go into step 6, we find the pivot row. All right? And when it says locate the most negative indicator, if there are 2 such indicators, choose the one farther to the left. What that means is if both of these numbers had been negative 25, which do I choose? I choose the one closest to the left. So that's addressing the pivot column. Pivot row says form the necessary quotients to find the pivot. Disregard any quotients with 0 or negative number in the denominator. So, meaning it needs to be a positive quotient. Let's talk about how to find that quotient. So, this one's a little bit easier because there's only one positive number, and it's 4. Well, how will I determine that? I'll take whatever numbers in the right-hand column, the right-hand side, and divide by the number or the entry in the pivot column corresponding same row. So, 150 divided by 0. Okay? So we know we cannot divide by 0. That's what this is saying. Disregard any quotients with 0 or a negative number in the denominator. I'm going to have 0 in the denominator. So therefore I know this will not be my pivot row. I cannot divide by 0. Here I'll have 200 divided by 4. And if we divide 200 by 4, we get a quotient of 50. And 4 is neither negative nor 0. So I know I can use this quotient of 50. When I go here, I have 100, what's on the right-hand side, 100, and I'm going to divide by negative 2. And it told me to disregard any quotient that has a negative in the denominator. And if I were to write this as 100 over negative 2, it has a negative in the denominator, so I know I'm going to reject this row as well. So therefore, this is the pivot column, this is the pivot row, and this is where the 2 meet, so this would be my pivot element. And I would pivot about this element. And In the previous section, you learned what it means to pivot. That means that this 4 will remain a 4, and all other entries in that column, in the pivot column, all of these entries will become zeros. We will have to perform row operations that will change -2 to 0. The 0 is already 0, so it's there, and -25 to 0. Because basically we are making the pivot column a basic variable. Okay? So that's how we go about locating our pivot element. Okay? And we're going to go through and do this once again, but I also want to solve a problem. I want to be able to put it all together. So if you didn't quite understand those steps 5 and 6, we're about to go through a problem where we're going to be able to look at steps 1 through 9 and actually solve the problem. Okay? So we're going to go through those steps again just in case you need them. But I want to look at a problem from a previous section, and this would have been when we talked about linear programming and we looked at it from a graphical perspective. So a graphical approach to linear programming. But I want to show you that we can solve the same problem, we can set it up and solve it just as we did graphically. So I'm going to cover up, I guess I probably should have covered that to begin, but we'll begin here. And so when we look at this, we're going to go through each of these steps. So keep your steps out. If you've already printed them, keep them so you can follow through. And as I reference step 1, you'll know this is what I'm talking about as I reference step 6. So you'll be able to keep up with the steps. Okay? So let's say I want to solve this problem. First thing I need to do is read it carefully and be sure that I have a really good understanding of what they are asking. So I'm going to read it, and you can read it at home. It says, Mr. Tranga, and I hope you can see that, Mr. Tranga plans to start a new business called River Explorers, which will rent canoes and kayaks to people to travel 10 miles down the Clarion River in Cook Forest State Park. He has $45,000 to purchase new boats. He can buy the canoes for $600 each and the kayaks for $750 each. His facility can hold up to 65 boats. The canoes will rent for $25 a day and the kayaks will rent for $30 a day. How many canoes and how many kayaks should he buy to earn the most revenue? So this is a typical linear programming problem. We are trying to maximize our profit. We're trying to maximize under certain limitations, which we call constraints. So when we talked about this, and as you looked at videos, whether in my math lab or in class we've solved this, you know the very first step is we want to be able to identify our unknowns. And that can be found from this very last sentence. So it says, how many canoes and how many kayaks should he buy to earn the most revenue? So with the Simplex method, we do not want to use X and Y's anymore. We want to be consistent, and you'll see why when we get to the next section when we minimize using the dual problem. And so instead of X and Y, we use X1 and X2. And I'm going to let X1 be how many canoes he would need to buy. So I'm going to call this the number of canoes. And hopefully you can see that. I might need to write with that. Let's see, let's try this blue one. And X2, the number of kayaks. So, number of kayaks. Okay? And so that's my X1. This is our X2. So we've identified our unknowns. And that usually comes from that last sentence. Well, if you recall, there is a form that we like to write these in. So we're going to maximize. Maybe I need to use more of a marker. So we're going to maximize, and our linear objective function, our profit function that we want to maximize, we can call it P, we can call it Z. I'm going to call it Z equals, now let's see. It says that canoes will rent for $25 a day. So if canoes are renting for $25 a day, that's 25 times X1. Okay? And if the if the kayaks rent for $30 a day, that's 30 times X2, since X is the number of kayaks. So this is our linear objective function, which we will maximize. Okay? And so now we know that this is always subject, because these aren't new to us. So they're subject to constraints. And we think of our constraints as limitations. So let's talk about some of these constraints. So we know that we have a storage constraint and we have money constraint or limitations. He has $45,000 to purchase new boats. He cannot spend more than he has, so he won't spend more than that. And we also know that his facility can hold up to 65 boats. So his facility can only hold up to 65 boats. So that tells me however many canoes he purchases, X1, plus the number of kayaks, must be less than or equal to 65. That's one of our limitations. That's one of our constraints. Okay? And if you recall, our constraints, I'm going to lift this just a bit, our constraints are written as linear inequalities, right? And so now our other constraint we said is money. He has only $45,000 to purchase new boats. So that means he's going to spend less than or equal to $45,000. He can't exceed that. So this is one of our limitations, so to speak. Now, this is a money constraint. This is a storage constraint. Well, with money, let's see, how much does it cost for him to purchase a canoe? So he has $600 to purchase each canoe. That's how much it costs. And his kayaks are $750. And so X2 represents kayaks. So we have so far two constraints, a storage constraint and a money constraint. And we also have our non-negativity constraints. And let's talk, those are important. And they were especially important when we were graphing. These kept our graphs, these two constraints kept our graph in the first quadrant, if you recall, from the previous chapter. And they're important here because we wouldn't say, since X1 represents the number of canoes, we're not going to say he's going to purchase -1 or -2 canoes. We know he may not purchase any, so that's 0. So it could be equal to 0, or he's going to purchase a positive number, 1 canoe, 2 canoes, 10 canoes. That's what we're trying to find. So these are our non-negativity constraints. So we are maximizing this linear objective function, which is going to be subject to these 4 constraints. Now, if you recall, oftentimes we like to reduce these numbers. They may come a little bit smaller if we can. And in this case, we can definitely divide them. We can make these, I should say, smaller numbers, right? So let's do that. So when we find the number, the largest number that will go into 600, 750, 45,000, and we divide each of those by that number, we'll end up with this one. And I'm just going to change this one. And I'm going to kind of write it out over to the side. So I'm going to rewrite this in its reduced form, so to speak, right? So if we reduce it, this is our reduced form. It'll become 4x plus 5y is less than or equal to 300. So that's what we have for our new constraint. So if we wanted to rewrite it, we could say that we are maximizing subject to this 1. This is our second constraint, and then these 2. Okay? This is if we are reducing. All right, so that's how we set this up. And if you recall, this is, and what we did was we just divided each one by 150. That's what I did here. So I divided each one of these by 150. All right, so 600 divided by 150 is 4. 750 divided by 150 is 5. 45,000 divided by 150 is 300. So we can reduce this down to 4x plus 5y less than or equal to 300. So if you go back to the steps for just a second, let's see what we've done. We determined the linear objective function, which is z equals 25x1 plus 30x2. We wrote all of the necessary constraints. We had a storage constraint, we have a money constraint, or we could say storage limitations, money limitations. That's step 2. And now we want to go to step 3. This was a step that in the previous chapter, when we looked at a graphical approach, we didn't have to worry about because we were graphing these linear inequalities. But because we want to use them we want to place them into a Tableau, which is just a fancy matrix, we do need these to be equations. So at that step now, step 3, we are going to, this is step 3, we're going to convert these inequalities to equations by introducing slack variables. And so we could rewrite this as x1 plus x2 plus your first slack variable, and set this equal to 65. We need these to be equations so that we can enter them into our matrix, our Tableau. So my next one would be 4x. Let's see, 4x plus 5y plus a second slack variable to set this equal to 300. Two different inequalities, two different slack variables. And then our last step, if you recall, our last step is our linear objective function. And remember, with this linear objective function, we do need to have 0 on the right, so we need to move x1 and x2 to the left side. I want z to remain, its coefficient to remain positive 1. So I'm going to subtract these two, moving them to the left side. So I'll do that now. When I subtract these two from the right side, I'll have 0 on the left. And on the right, I'll have negative 25x1 minus 30x2 plus z. Okay, so that's step 3. We have gone through the first 3 steps. We read the problem. We're trying to help Mr. Tranger to be able to earn the most revenue. We want to maximize his profit. And so we went through, we set it up. We set up our linear objective function, our constraints, and now our slack variables. So our fourth step is step 4, and I might do this on a different sheet. I'm running out of paper. I'll write really large. So step 4 would be, now we need our initial Tableau. So I'm going to get another sheet of paper. So I'll go back to this one if we need to, but I'm going to get another sheet. And using what we found in step 3 that you can see here, what we're using in step 3, I'm going to set up our initial Tableau. That's step 4. So our initial Tableau. All right? And so with our initial Tableau, we are going to have an x1 column, an x2, an s1, an s2, a z, and of course we have these numbers on the right-hand side. And so I'm going to go forward and use my coefficients. I have 1x1, 1x2. I have 1s1. I have no s2 in that first equation, no z variable, and on the right-hand side, I have 65. And then now, I have 4, I have 5, I have no s1 in the second equation. The equations are rows, but I do have a coefficient of of 1 for s2, I'm sorry, and then no z and 300. All right. And now my linear objective, or what we called before our indicator row. For our indicator row, we have negative 25 is the coefficient of x1, negative 30, no s1, no s2, 1, and then a 0. And notice, we check it, our s's and our z's, we have 1s on the diagonal, 0s above and beneath. Kind of looks like it's in reduced row echelon form, right? So this is our initial Tableau. That is step 4. So we have gone through the steps, we've set up our initial Tableau, and now we are ready to, and I bet you guessed it, we are ready to, at step 5, locate our pivot element so that we are able to pivot. Okay? So let's go through and take a look. Let's give it a try. So this is step 5. We're going to find the pivot column, and then step 6, we're going to find the pivot row. So to find the pivot column, we go to the indicator row. I like to refer to this as the indicator row, and it's going to indicate a lot to us. It indicates what our pivot column is. It indicates when we are to stop and we've reached a final Tableau. So this is our indicator row, and the most negative number is negative 30. So in red, I'm going to mark that. X2 column is, because negative 30 is the most negative number, this is my pivot column. All right, and remember, if I have I have negative 30 here and negative 30 here, I want to choose the column that's closest to the left side so that we can all just be on the same page. That's why we did, so that we can say we will all choose the one that's closest. But it's not in this case. This is the most negative, clearly. So I know that this is my pivot column. When I look up, I do have positives, so I know that I can continue. If I were to look up and had two negative numbers, or I had a negative and 0, if I looked above, when I say look up, above this bottom row, at this negative 30 in its column, if I looked up and saw no positive numbers, then I would stop, and we would say that there's no maximum value that we could find. But I didn't. I looked up and there are positives, so now I have to find my pivot row. This is step 6. So I have to make a quotient, what I see on the right-hand side and the entry here, so I like to put it over here. 65 is the right-hand side divided by the element in the pivot column in that first row is 1, which gives me 65. 65 divided by 1 is 65. Then I have 300. So I can say 300, and then I want to divide that by 5, because that's the element in the pivot column for the second row, and that's going to give me 60. And so I have to choose the smallest quotient, the row with the smallest quotient. 60 is clearly smaller than 65, right? It's less than 65. 60 is less than 65. So I have found that row 2 is my pivot row. So where the pivot row meets the pivot column, this is our pivot element. That is the element that we're going to pivot about. Okay? So let's talk a little bit about that. So we're going to pivot about 5, and I want you to recall what it means to pivot. A pivot is a specialized row operation. It's a row operation that would leave the pivot element, and in this case, the pivot element is 5. It's going to leave 5 as 5. We're not going to change it. We're going to leave it as 5, and then we are going to change all of the other elements in that column, which are 1 and negative 30. We're going to change those to zeros. Okay? And once we do that, we've pivoted. And if you remember, once you pivot, you find your row operation. So I need to find a row operation. I'm going to write it here. That's going to change row 1 so that this 1 is a 0, and a row operation that will change row 2 to a 0. This element in, row 3. That's not a 2. Row 3. I should make that a 3. That will change row 3, this element into a 0. And once I've done that, I've pivoted 1 time. All right? And we're going to leave this 5 as a 5, and that way we avoid fractions. Okay? So what, and you might want to stop the video at this point and kind of think about what your row operation will be. What row operation will you perform using 5 that will, when I multiply a number by 5, and then multiply this by a number, and when I add them together, I'll get 0. That's the row operation we're looking for. Now, because we are pivoting, I want you to remember, in the previous section, I reminded you, or the video that you watched reminded you, that you cannot interchange these rows anymore. When we worked in the previous couple of chapters ago, when we talked about solving a system of linear equations using a matrix, you were allowed to interchange rows. We can no longer interchange rows. Also, we are only able to multiply the pivot row by a negative number. The rows that are changing cannot be multiplied by negative. So, if I need a negative, it has to come from the pivot row. Keep that in mind. If you do not abide by that rule, you may get a negative in this right-hand side. And if you do get a negative in the right-hand side, you've gone wrong somewhere. So be sure. So let's see what a row operation could be. And you might want to stop the video and kind of think on what your row operation will be. What do you think you would do? And then turn it back on to see if you're correct. And we're going to try to use integer values so that we do not have fractions. So let's see. So I need to add these two together and get 0. So one of them has to be negative 5. It's already a 5, so I need this one to become a negative 5 and this one to become a positive 5. And the reason why I want to multiply row 2 by a negative is because I can only multiply the pivot row by a negative. So my row operation will be negative 1 times row 2. So negative 1 times 5 is negative 5, plus 5 times row 1. That's going to be my row operation. So negative 1 times 5 is negative 5, plus 5 times 1 is 5. So negative 5 plus 5 would give me a 0 for row 1. So this is my correct row operation. And remember, the pivot row is the only row that could be multiplied by a negative. Since row 1 is changing, I have to have a positive sign in front of it. I cannot multiply by negative. So let's look at this one. I have negative 30. I need to be able to add two numbers together to get 0. So I multiply this row by 6, this entire row by 6. I get 6 times 5 is 30, plus negative 30 is 0. So that means for this row operation, I'm going to have 6 times row 2 plus row 3. That's going to be my row operation. And remember, because this is the pivot element, I must use it. And if I needed to multiply anything by negative, it will any row by negative, in this case, it has to be row 2 because that is the pivot row. So these are my row operations, and I'm going to perform those. And you can turn off the video at this point. Pull out your calculator. You may want to use your graphing calculator to help you to be sure that you're adding and subtracting correctly. But I'm going to continue, and I'm going to write out, this is x1, x2, and I'm going to have an s1, s2, z on the right-hand side. And remember, these row operations must be performed on each one. And if I need to go through one, I will go through one with you, okay? So negative 1 times row 2 is negative 1 times 4 is a negative 4, plus 5 times 1. So negative 4 plus 5 is 1. Okay? And if you'd like, let me go ahead and do this. I know that row 2 is not changing because it was the pivot row. So I'm just going to write the elements of that one. Row 2 is not changing. So there's 1. So then negative 1 times 5 is negative 5, plus 5 times 1 is 0. Negative 1 times 0, so negative 1 times the element of row 2, negative 1 times 0 is 0, plus 1 times 5. So 0 plus 5 is, and we get 5. And if we continue with that pattern, we'd have negative 1, 0, and 25. Okay, let's start. 6 times 4 is 24, and 24 plus negative 25 is negative 1. Okay, 6 times 5 is 30, plus negative 30 is 0, and then 6 times 0 is 0, plus 0 is 0, and then we could continue. We'll get 6, 1, and 1,800. So we have pivoted one time, and now we stop. Once we've pivoted one time, we want to remember, always check your indicator row. So this bottom row is the I sometimes call it the linear objective row or the indicator row. But remember, if we still have a negative, that means that we have not found our maximum. Okay? This means that we need to continue and pivot again. If I had non-negative numbers in this bottom row, then a maximum value has been found. But what this is telling me, if you think about this from a graphical perspective, because that's where we spend a lot of time in the past few weeks, is solving linear programming problems using the graphical approach. What this is really telling me is that I'm at a specific corner point, and I have not maximized the linear objective function. So when we pivot, it's as if we're going from one corner point to another, and then we're going to test to see, does that corner point maximize the linear objective function? So it's like we're pivoting, we're moving from one corner point to an adjacent to another corner point. And that's what this process of the simplex method is doing when we think about it from a graphical perspective, okay? So what this negative 1 in the denominator is telling me is that we're at a corner point, and that corner point does not maximize the linear objective function. It does not maximize our profit function. So we keep going. So we have to pivot once more. And where I am in this process, if you're looking at your steps, if you're like, which step is she on? Right now, I am on steps 7 and 8. Okay? So basically, 7 and 8 says, okay, once you pivot it, now if you still have a negative, go back to steps 5 and 6. So I'll do that. I'll go back and find my pivot column and my pivot row. So as I'm looking at this, I see that there's only one negative. The smallest negative number is negative 1. So our pivot column is found. I look up, I know I can continue because I have positive numbers above the negative 1 in the pivot column. So to find my pivot row, I'm going to take the number on the right-hand side and divide it by the number in the pivot column, which is 1. That gives me a quotient of 25. I have 300 here, so I'm going to have 300 divided by 4. And then when I divide 300 by 4, I'm going to get a quotient of 75. And remember, our rule is our pivot row will be the row with the smallest quotient. The smallest, and I should say non-negative quotient. The smallest quotient that is not negative. And remember, we cannot have 0 either. We can't have 0 in the denominator. So the number in which we're divided by can't be 0. So 25 is our smallest, which tells me that row 1 is now my pivot row. So my pivot column is column 1. My pivot row is row 1. Where they meet is my pivot element, which in this case will be 1. So this time around, I'm going to pivot about 1. And you know what that means. To pivot means that the 1 will remain a 1. We're lucky here. It's 1. It's easier to work with. It's 1, and then we need to make 4 and -1 zeros. So we're going to perform row operations that will allow us to have zeros here. So I'm going to write these row operations. Let's see. So you might turn it off for a second so that you can come up with your own row operations. So, and I'm going to the right because I usually like to go to the right, but it's going to continue and my new matrix will be here once I pivot. So I need this to be a 4. This is my pivot row. So I want row 2. My row operation will become -4 times row 1 plus row 2. And the reason why is because, remember, only the pivot row can be multiplied by negative. The row that is changing, which in this case is row 2 and row 3, the rows that are changing, those rows cannot be multiplied by negative numbers. So -4 times row 1 plus row 2. And for row 3, these are already opposites. So for row 3, I'm just going to add row 1 plus row 3. And those are going to be the row operations that I perform. And remember, I have to multiply every single entry in row 1 by -4, and then add that product to the existing numbers in row 2, and then that's going to replace the elements of row 2. I replace the elements of row 2 with the sum of those two products. So let's do that. You can pause, I should say, not turn it off, but pause the video. And you can perform those row operations if you'd like, right? And so I'm just going to go ahead and write them in for time's sake. So I'm going to write them in. So what we will have, I know that I did not change row what? 1. So I'm just going to keep 1, 0, 5, -1, 0, 25. But my new entries will become 0, 5. When I perform this row operation, my row 2 becomes 0, 5, -20, 5, 0, and 200. Right? And row 3 becomes 0, 0, 5, 5, 1, and 1,825. So look at that. We have improved the profit value, right? So it's improved. It went from 18 to 1825. And we know this is our maximum, and hopefully you understand why. This is our maximum because we have no negatives in the bottom or the indicator row. So we know that we have found a maximum. Okay? So this is our final tableau. We are done. We do not have to pivot again, but we do have to read it. And we practiced that at the beginning of the video. So to read it, let's identify our basic variables. So we know we're going to have a basic variable here and here. So 1 times x1 is equal to 25. So 1x1 is 25. 5 times x2 is equal to what's on the right-hand side, 200. So 5x2 equals 200. And when I divide, because remember I'm solving for x2, and when I divide both sides by 5, I'm going to know that x2 is 200 divided by 5, which is 40. Non-basic variables are 0. These are non-BVs, right? Non-BVs are automatically 0, so I could say S1 is 0, and I could say S2 is 0. And 1 times Z is 1825. All right? So I see that it's as if I'm at a corner point. If I thought about this graphically, I'm at the corner point X, comma, Y. In the previous chapter, we called this X, we call this Y. We're at the corner point 2540, and we have reached a maximum of 18, and that is 18. I know it's hard to see in red, I'm sorry. 1825. Okay? But it's not enough to just give these answers and go through the motions. We have to really think about what we're saying. So I'm going to go back to, let's see if I can find it. I'm going to go back to that particular slide. Where is it? Let's see. I'm kind of got unorganized here. Here we go. So I'm going back, and I'm going to write this down. I'm going to write down that we found X1 to be 25. And X2 to be 40. And if you go back for a second, I know I have X's and Y's here because we had X's and Y's when we looked at this problem before, but go back, recall, X1 is the number of canoes. I'll go back here. X1 is the number of canoes, X2 is the number of kayaks. So this is canoes, just in case you can't see it well. And this is kayaks. The lighting in this room is so strong, and it makes it difficult sometimes for the overhead, but that's what we have. So by saying that we found X1 to be, was it 25? And we found X2 to be 40, and we found Z to be 1,825. What this actually says, let me see if I can get, there we go, is that we can actually answer our question. And so our question, if we go back to the problem, it says how many canoes and how many kayaks should he buy to earn the most revenue? So this means that Mr. Tranga should buy 25 canoes, because X1 represents the number of canoes, and he should buy 40 kayaks in order to maximize his profit in order to have a maximum value of $1,825. Okay, so this answers our question, and we've answered this question before, but using the graphical approach, and this time we use the simplex method. Okay, so I want you to be able to not only read these, I want you to be able to set them up as well. Okay, all right. So we've gone through one problem from beginning to end. We've set it up ourselves, and I'm going to go through and let's see if there's time. Let's do one more. You may or may not need this one, or you might want to solve this one at home on your own. Okay, this is one that you may have seen before. So let's go back. So I want to go back for a second, and we're going to solve this one. So let's go back and look at it, and this will be the last one. So just to be sure, but turn off the video if you think that you want to attempt it on your own, and then you can turn it back on and go through the steps with me if you like, okay? So let's do that. So I want you to take a moment and read through it, and then we'll solve it together, all right? So it says, a farmer has 100 acres of available land on which he wishes to plant a mixture of potatoes, corn, and cabbage. It costs $400 to produce an acre of potatoes, $160 to produce an acre of corn, and $280 to produce an acre of cabbage. He has a maximum of $20,000 to spend. He makes a profit of $120 per acre of potatoes, $40 per acre of corn, and $60 per acre of cabbage. How many acres of each crop should he plant to maximize his profit? So it's a lot going on here, and in this problem, though, it's very similar to the problems we worked when we were looking at a graphical approach, but this time we have 3 unknowns because it says how many acres of each crop. He has 3 crops. So it is difficult to graph this. It's not as if we're graphing X and Y. We're going 3-dimensional X, Y, Z, and it would be difficult to graph. And if he had 4 crops, let's say potatoes, corn, cabbage, and maybe, I can't think of rice or something else that he's trying to plant, then we could not solve this graphically. So this is why the simplex method is so important, right? And so let's set this problem up. So we begin by knowing that we read the bottom. How many acres of each crop should he plant to maximize his profit? Well, in order to maximize, so let's see, x1, and we could let that be since potatoes is first. How many acres? So we'll say the number of acres or just acres of, and in this case I'm sure just potatoes. Okay, and x2 could be acres of corn that he would need to plant, right? But I'm shortening this, just I shortened it just a bit. X3 is the acres of cabbage, right? Okay. Excuse me. So we know that we're trying to maximize his profit. So we want to maximize profit, and we can call that Z, or we could call it P. It's up to us. So I'm just gonna use Z because I like Z, but I could use P. So we want to maximize Z equals 2. Let's talk about how much he will make. What is his profit? What do they tell us? And that statement is usually somewhere before our last sentence, which it says he makes a profit of $120. So $120 per acre of potatoes. So that's our 120x1. And then it says he makes 40 per acre of corn, and corn, we use x2 to represent corn. And then $60 per acre of cabbage. So this is our money function. This is our linear objective function, which will be maximized. Okay? So this is what we're trying to maximize, our profit function. And we know we always have limitations. So I'm going to say subject to, instead of limitations, we'll call them constraints. But you want to think when you're creating these constraints, what are his limits? Well, let's just start. We know that x1, x2, and x3 have to be greater than or equal to 0, right? Because we do not want to say we're going to plant -2 acres of potatoes, negative acres of corn. We're either going to plant nothing, which would be 0, or something positive, 1 acre, 2 acres, 100 acres. So we have our non-negativity constraints here. Well, we're going to go back up, and now we want to think about what other limitations do we have. Right in the first sentence, it says the farmer has 100 acres of available land. So however many acres of potatoes plus the acres of corn plus the acres of cabbage that he plants cannot exceed. So x1 plus x2 plus x3 can be less than or equal to 100. So he can plant less than 100 acres. He can plant 10 or 50 or 60 or 95, but he cannot, or up to 100, he cannot exceed. And remember, when a maximum problem is in standard form, the constraints must be less than or equal to a positive number. So keep that in mind. We want it to be in standard form. And now our next constraint is money. He has a maximum of $20,000 to spend. So that means he's going to spend either exactly $20,000 or less than $20,000, right? Running out of space here. So how much, let's talk money. This is our money limitation, so we want to know how much does it cost him to produce each acre? Well, it costs $400 to produce an acre of potatoes. So potatoes, x1 is what represents potatoes, so 400 x1. And 160 to produce acres of corn, an acre of corn, I'm sorry. So 160 times x2 plus $280 to produce an acre of cabbage. So 280 x3. And this is our linear programming problem setup. And I know this is a little tight, but it's 400 x1 plus 160 x2 plus 280 x3 is less than or equal to 20,000. This is our money limitation. This is our land limitation. And again, if I want to rewrite this or make this a little bit better, I can change this. I can definitely reduce it. Okay, so that is something that we can go through and do. So we can divide, and let's see, the greatest common factor for 400, 160, 280, and 20,000 is going to be 40. Okay, but let's say you just thought, oh, well, I just wanted to use 10. That's fine. You're just going to be working with larger numbers, but in the end, whether you reduce it by 40 or reduce it by 10, or whether you don't reduce it at all, you should still come out with the same answer in the end. Okay, so I'm going to change these constraints. I'm just going to rewrite them as x1 plus x2 plus x3 less than or equal to 100. And when I divide each of these numbers in the second constraint by 40, I will have 10x1 plus 4x2 plus 7x3 is less than or equal to 500. All right? And I still have x1, x2, and x3 greater than or equal to 0. So this is the problem. This is how we have converted it to mathematical terms. So from the words of the problem to a mathematical linear programming problem or expression, right? So this is what we have. So that's steps 1, 2, and 3. And now go to step 4, and I bet you guessed it. Step 4 is let's introduce our slack variables. So step 4, step 3, I skipped. This is steps 1 and 2. Step 3 is we're going to introduce our slack variables. And remember, we are not graphing this. It's going to be difficult to graph. We have x1, x2, and x3. So it's like saying we have x, y, and z, and we're no longer two-dimensional, we're three-dimensional. It's difficult. So we do not want to graph these inequalities. We want to convert them using slack variables to equations so that we can then enter them into our fancy matrix, which we call a Tableau. So we're going to change this. This is going to become x1 plus x2 plus x3 plus our first slack variable equals 100. Think of this as taking up the slack so that it's not less than 100 is equal to 100. 10x1 plus 4x2 plus 7x3 plus s2 is 500. And do not forget, the last row is the last thing you do is look at your linear objective function. And we are going to move every one of these terms, 120x1, 40x2, and 60x3 to the left. So we have to subtract them from the right. So when we do that, we'll have 0 on the right, negative 120x1 on the left, negative 40x2 on the left, minus 60x3, plus the z that is already there. So this is what we have. What is our next step? We're going to take these equations now and enter them into our step 4 initial Tableau. Okay? So let's see. How are we going to do that? So, our initial step 4. I'm running out of black ink here, right? My initial Tableau. Here we have our slack variables, our linear objective row. We have an x1, an x2, and this time an x3, an s1, have 2 slack variables, see? And then we have these numbers on the right-hand side. My coefficients, if I go across, what are my coefficients now? These coefficients are 1, 1, 1, 1, 0, 0, 100. So 1, 1, 1, 0. I'm sorry, 1, 1, 1, 1. Because I do have an S1 here. This should be a 1. Please forgive me. 0, 0, and 100. Then I have 10, 4, 7, 0 for S1, 1 for S2. Because remember these coefficients. That's what I'm looking at. Hopefully you can see that. And so this becomes 10, 4, 7, 0, 1, 0, 500. And then I have my indicator row, which is negative 120, negative 40, negative 60, 0, 0, 1, and 0. And we can start. All right? So this now is our initial Tableau. And I'm going to keep this handy because I'm going to come back to it, right? So I need to place it where I won't lose it. All right. So let's go through now. We want to go through the steps one last time. We need to find, this is step 5, we need to find our pivot column. So as we look at this, we have all, let's see, our most negative number is negative 120. So this is our pivot column. That's the easier one to find, right? And I look up, I have positive numbers, so I know I can continue. I will be able to pivot. I'm going to divide 100 by 1, which is 100. And I'm going to divide 500 by 10, which is 50. And 50 is the smaller quotient. So 100 divided by 1, and remember, we always choose the smaller quotient. So that means that this is my pivot row. And when my pivot row meets my pivot column, 10 is my pivot element. So that's how I decide my pivot element. In case you ever have two of the same such, so if this had been 50 and this had been 50, just choose the one that's closest to the top of the matrix, okay? So if this were 50 and this were 50 and the quotients are equal, just choose the one closest to the top. But in this case, that was not the case, so I chose 10. All right? So now we need to come up with our row operations that will change this to a 0 and this to a 0. So I need a row operation for row 1. I need a row operation for row 3. And I'm going to write them down. I like to write them off to the side, but I write really large, so just bear with me. The row operation for row 1, and then I need one for row what? 3. And hopefully you'll see that this is 10, and you remember that you can only multiply the pivot row by a negative. So if I need to make this negative 10 and this positive 10, my row operation will be negative 1 times row 2 to make this a negative 10 plus 10 times row 1. That's going to be my row operation because negative 1 times 10 is negative 10. 10 times 1 is positive 10. Add them together, I'll have 0. And I'm going to perform this these operations on every single entry here. And so for row 3, I have negative 120. 10 times 12 is 120. So 12 times row 2 plus row 3 will be my row operation for row 3. And you can stop and perform these row operations. If you're still having trouble with the row operations, you need to come in and see me during my office hours, or you could visit one of our mini tutorial labs, or you could visit our online tutoring center if you continue to have problems with the row operations. So if you find your row operations but you're having trouble performing them, then you need to definitely see me. So I'm going to write 10 because we know that row 2 is not changing. That's the pivot row, so it's not changing. These are 7s. Sometimes my 7s look like 1s, so I'll cross 10 times. All right. And so now let's see. When I perform these row operations to save time, I'm going to go ahead and fill them in, but you can turn off the video and fill them in for yourself if you'd like, and then check to see that you did it correctly. But they're going to be 0, 6, 3, 10, negative 1, 0, 500. And then here, 0, 8, 24, 0, 12, 1, and 6,000. I did these right before I hit the record button to save a little time. And hopefully now you see our indicator row has no negative numbers. So all the numbers are non-negative, 0 or positive, right? So we have reached a final Tableau because our indicator row has all non-negative numbers, right? 0 or positive. So now we need to read. And what we really want, we can read all of them, but what's most important are the values for x1, x2, and x3. And if we were graphing, it's like saying we have found a corner point that maximizes the linear objective function. All right? So, and this time we only had a pivot once. So let's go back and read. 10x1, 10 times x1 equals 500. So when I solve for x1 by dividing both by 10, I get 50. x2 is not a basic variable because look at its column. It doesn't have just, look at x1, it has zeros and one non-zero digit. It is a basic variable. x2 is not, so we know automatically that x2 is 0. x3 is 0. That's how we read it. S1 is going to end up being 10s1 equals 500, which is 50. S2 is 0. And Z is 6,000 because I have a 1. So 1 times Z is 6,000. So It's like saying we're at a corner point 50, 0, 0, and we've reached a maximum of 6,000. That's our maximum. But we want to be sure we're answering the question. So if I go back for just a second and I look at this, this is our problem. The question was, how many acres of each crop should he plant to maximize his profit? And we have found, we said X1 is corn, so he needs to plant 50 acres of corn, right? He needs to plant no acres of, 50 acres of, this is potatoes. Let me write this so I won't forget. X1. X2 is corn, so 50 acres. This is corn. I'm sorry. Oh, I'm just writing this wrong. I was thinking the video was going to cut off after 1 hour and it didn't, so I was trying to rush it. I am sorry. Let's go back and not rush it. This is why we don't rush in math. Let's look at it again. X1 was 50, X2 was 0, and X3 was 0. I want to be sure I get that right. And I'm going to go back here. This is what I'm looking at. X1 represents acres of corn, potatoes, X2 acres of corn, and X3 acres of cabbage. So let's fill in. We said X1 is 50, so I'm going to put 50. And X2 is 0. X2 is 0. All right, and we go back again, and X3 is 0. So X3 is 0. All right, so this is telling us, if you can see it, let's kind of organize this a little bit better. I don't need that one now. So we'll say that if we're going back, he needs to plant 50 acres of potatoes, no acres of corn. This lighting is horrible. Maybe this will be a little bit better. 50 acres of potatoes, 0 acres of corn, and 0 acres of cabbage in order to reach a maximum profit of, and that number for Z was 6,000. So that's his maximum. So the question asks, if we go back to this page, how many acres of each crop should he plant? He should plant 50 acres of potatoes, no acres of corn, and no acres of cabbage. And it does seem strange that he should leave his land unfarmed, but it does make sense mathematically, and if he wants to maximize his profit. So he will reach a maximum profit of 6,000 if he only plants 50 acres of potatoes. Okay? And if you were to look at, if we go back and kind of look at this for just a second, that is our correct answer. So he should plant 50 acres of potatoes, no acres of corn, and no acres of cabbage. If we go back for a second, that's what this S1 represents, the 50 acres that he will not plant at all. 50 acres that he will not use at all. Right? That's what that represents. But what's most important is this X1, this X2, and this X3, and his profit. So there is a maximum profit of $6,000 when he plants 50 acres of potatoes. Okay? So I hope that problem helped you to be able to get a really good understanding of how we go about solving linear programming problems using the Simplex method. And again, if you're interested in the books that I use for these problems, these are the 2 books that I reference in each of these slides. Thank you.